Okay, now we're going to talk about how to factor binomials. Binomials are two terms. So the first thing is a difference of squares, which should look familiar. We need to remember to always check for a GCF first, and we have to check for these other three things. Are they all perfect squares? Do I have a binomial? And do I have subtraction, thus the difference? The way I like to think of it is use the first letter, difference, D, of O, squares, S, so dos. And what does that mean in Spanish? Two. What does a binomial mean? Two terms. What number do you think of when you think of perfect squares? Two. When you square something, you raise it to the second power. Also, perfect squares with variables means we're looking for even exponents. So looking at some basic problems, I always need to check, do I have a GCF? No. Do I have two terms? Yes. Subtraction? Yes. And perfect squares? Yes. So then we write what I call the structure, which is parentheses, parentheses, plus, minus. Then we do the square root of the first term, and that goes first. And then we do the square root of the last term, and that goes last. And you're done with a difference of squares problem. Going down, I have two terms, subtraction and perfect squares, no GCF, so I put my structure, parentheses, parentheses, plus, minus, square root of the first would be 11x squared, and that goes first. And then I do square root of the last, so the square root of 144 is 12. My next problem does have a GCF, so I have a 2 that I can take out, and that leaves me with x squared minus 16. Now that x squared minus 16 is a difference of squares, so parentheses, parentheses, plus, minus, square root of the first would be x, square root of the last would be 4, and then I just need to put my GCF of 2 in the front. My next problem has a GCF of 16. And you may not have seen 16 first. Maybe you saw 4 first. But once you take out the 4, you would see you still have a GCF. You still have another factor, common factor. Okay, so 64 divided by 16 would give me 4. So 4x to the 6th minus y to the 4th. I have two terms, subtraction, perfect squares, even exponents. So I put the structure of my problem, plus minus, square root of the first, 2, and now we need to divide our exponent by 2. So this would be x cubed, 2x cubed. And then I do the square root of my second term, which would be y squared. And make sure you put your GCF in front. Now I'm going to scroll down a little bit because I put these in the wrong order and can't change it. Now we have the OMG fractions, but they really aren't a big deal. So you're still looking for everything to be perfect squares. Now you want every part of your fraction to be a perfect square, which I have in both these problems. So I do parentheses, parentheses, plus, minus. Then I do the square root of 1, which is 1, the square root of 49, which is 7, and the square root of x squared is x. Square root of 9 is 3. Square root of 64 is 8, and the square root of y to the 4th is y squared. So it's the same idea, it's just I'm going to have to do my square root a couple more times. Same thing goes for the next one. Put your structure, parentheses, parentheses, plus, minus. Try to leave yourself a little bit more room when we have the fractions. So the square root of 9 over 100 would be 3 over 10. So that's my coefficient. And then I would have the square root of x to the 4th, which would be x squared. And then I do the square root of my second fraction. So square root of 1 is 1. Square root of 4 is 2. and the square root of y squared is y. So your answer is not what I would call pretty, but that is all there is to a difference of squares. That's as hard as it gets. Okay. The next thing we're going to talk about is a sum and difference of cubes. It's kind of similar to a difference of squares, but we're looking for cubes now. So it's still going to be a binomial, and you want perfect cubes. So here are these two complicated kind of formulas that if you want you can memorize. But what I do is I use something called SOMOS, which is a mnemonic device to help me remember what's going on. So like with difference of squares, we're going to have a structure, and it's either something cubed plus something cubed or something cubed minus something cubed. So the first thing is I'm going to write my binomial that comes from that. So that would be whatever's being cubed, your sign, and then the second thing being cubed. After that, to remember the trinomial, what I think of it as is you're going to square, so that's the S, square your first term, then you're going to write opposite sign, then you're going to multiply your two terms. You always add, and then you square your second term. So let's look at that, what that is in a problem. So this first one is a sum of cubes. So the first thing I do is rewrite it, which would be 3x cubed plus 2 cubed. So all I did was rewrite my binomial as 3x quantity cubed plus 2 cubed. Now what I'm going to do is bring down my binomial. So I bring down the 3x, I bring down the plus, and I bring down the 2. Now I do SOMOS. I square my first term. So that would be 9x squared, because 3x squared is 9x squared. I do the opposite sign, which would be, since it's a plus, would be a minus. I multiply my two terms. 3x times 2 is 6x. I always add, so I put a plus. And I square my second term. So 2 squared is 4. And that ugly thing is my final answer. So writing, excuse me, rewriting my second problem would be 5x cubed minus 1 cubed. So I'm going to write my binomial, 5x minus 1. Then I'm going to square my first term, so that would be 25x squared. I do the opposite sign, so that would be plus. I multiply my terms, so 5x times 1 would be 5x. I always add, and I square my last term, so 1 squared is 1. You don't have to write the letters underneath, I'm just trying to kind of keep track of what's going on. Now, this next problem, I noticed right off the bat, I have a GCF. 4 goes into both of those. So I want to take out the 4, and I'm just going to kind of put that over there on my final answer. That leaves me with a cubed plus 8b cubed, which would change my structure to a cubed plus 2b cubed. So now I'm going to do SOMOS. Write your binomial, so a plus 2b times, square your first term, a squared, opposite sign, makes it a minus, multiply terms, so that would be 2ab, always add, and square your second term. The main thing with the squaring is make sure you're also squaring your variable. Most of the time people remember to square the number, but not necessarily the variable. Okay, and the last one, I can rewrite as y cubed minus 3x cubed. So my binomial would be y minus 3x. Then I'm going to square my first term, y squared. Opposite sign, which would be adding. multiply my terms, which would be 3xy. I always add, and I square my last term. Now, the other nice thing about SOMAS is that it doesn't matter whether I'm doing the adding, the sum, or the subtracting. Both of them follow SOMAS. All that's really changing is my my operation where I have the opposite sign. All right, that's it. So review those examples a couple more times, especially sum and difference of cubes, since you might not have seen that.